Hello everyone, we are Jiezhao Wang and Yukun Shi. Today we are going to talk about conversion of 3G, 4G and 5G security mechanism. The first thing we want to introduce is the 3G security mechanism. Secondly, it's 4G security mechanism. Next is 5G security mechanism. And the last one is conversion of 3G, 4G, and 5G. This section shows the content of the 3G. The AKA of UMTS consists of the three parts. The first part is the home environment. The second part is serving network, and the last part is the terminal. Ciphering mechanism. After the user and network authentication ends, encryption is also required. The encryption and the decryption process occur in the RNC. Therefore, the CK needs to be written into the RNC from the CN. When the RNC receives the CK, it sends a command to the RRC to unlock the encryption. These two pictures show encryption algorithm and the integrity protection algorithm. These features are content of the 4G. EPS security architecture. The system will first confirm the UE, which will be acquired by the MME to verify and identity. And then the MME will perform the AKA protocol with UE. After the AKA protocol is completed, the key KASME will be shared by the MME and the UE. The NAS protection section indicated that the key will protect the data between the two structures MME and UE. Another key is sent to the eNodeB to generate three additional secret keys that are used to protect data and under AS protection by the eNodeB and the UE. The NAS security establishment process is performed by the NAS signaling and between the UE and the MME. The MME sends a message to the UE and the message security mode command the UE to send a message to the MME. The AS security establishment is a little different from the NAS security establishment. This is protection mechanism. The left one is a confidentiality mechanism, and the right one is an integrity mechanism. These are various risks in EPS security features, which need to be solved in various ways. EPS AKA. For EPS AKA, the role of the MME is equivalent to the VLR or SGSN in the UMTS AKA, and the MME can perform other functions where the VLR or SGSN cannot be implemented, where the mobile devices is similar to the HSS, but the difference is the USIM can be repeated use. The EPS AKA procedure. First, the HSS need to generate the authenticate vectors capable of DPS authentication according to the MME receiving the request from the MME, and then delivers it to the MME, and then authenticate between the SN and the UE. It will generate a new shared secret and finally send the authentication data to each location. EPS authentication vectors. After the MME request from the HSS generated an authentication vector EPS-AV. EPS-K hierarchy is divided into the 4 layers. From top to the bottom is the USM-AUC layer, UEHSS layer, UEMME layer, and the UEINV layer. The derivation direction of the key is always derived from the lower level to the higher level.
The following is an introduction to the 5G security mechanism. There are 3 main aspects. The first is 5G network security problems, then the 5G basic security mechanism, and the final is the 5G related technology security mechanism. 5G is different from previous communication technologies. With more capabilities, it will also face more network security challenges. This picture shows the main security issues facing 5G. To better cope with 5G potential security issues, safety standardism is a very important topic. The table below identifies the major organizations involved in the 5G security standard and their area of research. The first security mechanism is EAP authentication, which is also a challenging and response control based on the encryption key shared between the UE and its home network. It achieves the same level of security as 5G aka. Note that the EAP message is encapsulated in the NAS message between the UE and the SEAF, and in the 5G services message between the SEAF and the AUSF. AKA can be seen as the most important security mechanism. In 5G AKA, SEAF can begin the authentication process after receiving any signal's message from the UE. In addition, the UE's prominent identifier will never be sent in clear text on the 5G radio network. For the predecessor such as 4G, this feature is considered a major security improvement. This is the key hierarchy of 5G. The key setting occurs at the end of the successful verification process. Once the AFM knows the identity of the mobile user, the key setting can be made. In addition, 5G supports selective EAP-based secondary authentication between the UE and the external data network. This helps to strengthen the overall security of the network. And there are some other 5G security mechanisms as shown. The following shows the comparison of the security mechanism of 3G and 4G. 4G has further improvement than 3G in most areas. The figure shows the difference between the 4G and 5G key levels. We can find that the 5G security mechanism is more diverse and more complex. This chart highlights the differences between 4G and 5G authentication mechanism. 5G authentication is improved in many ways over 4G, including a unified authentication framework, better UE identity protection, enhanced home network control, and more key suppression in key diversion. Next, introduce the security mechanism of the three 5G key technologies. The first is a software-defined network technology that separates the control plane of the network device from the data plane, thereby enabling better control of network traffic. SDN's structure is divided into three lines, each of which also has its own unique security problems and mechanisms, as the picture shows. NFV technology, through hardware and software decoupling and functional abstraction, so that network device functions no longer depend on special hardware, resources can be fully shared. Because it's a virtual technology, the security issues and mechanisms that NFV face are completely different from traditional communication technologies. MEC technologies and cloud computing using the wireless access network to provide the services and cloud computing functions required by telecom users to create a carrier classes service environment with high performance, low latency, and high bandwidth. Virtualization and programmability will bring significant changes to next-generation networks. The following are related security mechanisms. Finally, in the future development of 5G security mechanism, the following challenges need to be faced.